Today, as you can see, we're going to take on this problem, March April 2024, and computer system in electrical and electronics engineering. Now, we were told that show that voltage, how to put divided by voltage input, which is transfer function, is given by 1 divided by tau 1, tau 2, s squared plus tau 1, s plus 1, where tau 1 is equals to L of R and tau 2 is equals to CR, in which, as you know, tau represents time constant. Now, I've combined R and C because they are in parallel. Call it Z. Now we have the simplified network containing the supply voltage only. The initial electrical network consisted supply voltage, then the supply voltage branched through R and capacitors. Now, first to get show, we have to combine the VL, which is voltage through L, plus VZ, which is voltage through the parallel parameters R and C. Now, first to get VO is given by, now VL, the voltage through L, which is the inductance times change in current divided by change in time, plus the VZ. Now let's work on VZ. Consists of R and C. So remember, the reactive capacitance is given by in our network using Laplace transform is 1 over Cs. So we have 1 over Cs. Now we multiply by R because it is in parallel. Remember this formula that two parallel resistance, let's say R1 and R2, in parallel with R2 is given by R1, R2 divided by R1 plus R2. So remember our capacitor or reactive capacitance is in parallel with R. Now you can multiply 1 over Cs times R divided by 1 over Cs plus R. Now we are going to get R over Cs divided by 1 of Cs plus R. Let's work on denominator. Now combine these two. 1 over Cs plus R divided by 1 is equals to Cs as our LCM. Then Cs divided by Cs is 1 times 1 plus Cs divided by 1 is Cs times R, which is RCS. Now we combine the two, the numerator and denominator, which is R over Cs plus all divided by 1 plus RCS divided by Cs. Mathematically, this Cs and this Cs will cancel out, and now we left with R of 1 plus RCS. Now, this represent the parallel parameters R and Z in Laplace transform. Now, for us now to get VZ, we take R over 1 plus RCS. Now this is multiplied by I, current. This is multiplied by current. Now we get, which gives us high R divided by 1 plus RCS, and I R divided by 1 plus RCS. Now this is a VZ. Now our VO is given by taking the Laplace transform of LDI or dt, LDI, Laplace transform of LDI or dt, we get LS. Change in time when it is not repeated gives us S. Remember that. When it is repeated gives us S squared, then I. And remember the integral, when we find the Laplace transform of integral, we get 1 divided by S. It is the opposite of the differentiation. So this is now a Laplace transform of the current passing through the inductor. Now our V in, this was our V in, this was our V input. Sorry, V input. Now our V input is equals to now LSI plus I R 1 plus RCS. This is equation 1, V in input. Now our voltage output given, it is a voltage through the parallel parameters or parallel branch relevant, which is VZ. And now we have the value of VZ. The value of VZ is VZ is equals to I R divided by 1 plus RCS. So our VO is equals to I R divided by 1 plus RCS. Now our transfer function TF is given by VO divided by VN. Our VO divided by VN. This is our VO, equation 2. This is our V in, call it equation 1. Now VO, the value of VO is I R 1 plus RCS divided by V in LSI plus I R divided by 1 plus RCS. Let's now work again with the denominator. LS, let's work on denominator. LSI plus I R divided by 1 plus RCS. Take the LCM. The LCM is 1 plus RCS. 1 plus RCS. 1 plus RCS. Now 1 plus RCS divided by 1 is 1 plus RCS. Now what by LSI? So it's LSI into 1 plus RCS plus 1 plus RCS divided by 1 plus RCS is 1 times I R. Now these are denominator. If we First of all, first step, you just combine these two parallel parameters, R and C. Now, for you to get the V voltage input, you have to get the voltage drop in VL and voltage drop in these parallel, in your parallel parameters, R and C. Now, this is how we go about it. Then, taking the Laplace transform of L, change in I over change in t, we get LSI. I've said the change in time gives us S. So that's why now we get LSI, but I now in capital, showing that it is transformed to the Laplace transform. Now remember, for us to have the ohmic value or the reactive capacitance now in the Laplace transform, we get 1 over Cs. And remember they are in parallel with R, which is resistance. So we get the product and the sum. After working with them, we will get R divided by 1 plus RCS. That is now the impedance through the parallel. Now, for us to get Vz, we have to multiply the impedance now with the current, which is supply current. That is Vz. Now, for the overall V input, voltage input, we take the LSI, which is Laplace transform of the voltage through inductor. We add the voltage through the parallel R and C. And now, if we work on it, we get LSI plus IR divided by 1 plus RCS. Now our VO, voltage output, is equals to Vz. Remember we have our Vz now, which is IR divided by 1 plus RCS. This is now our VO. Now transfer function is equals to V input, input or V output or V input. Now we rearrange them this way. This is now our V output, and this is now our V input. We work with denominator first, so that we have the common base. After working with denominator, we get LSI plus LS squared RCI plus IR divided by 1 plus RCS. Now, after placing the denominator to its place, now take the numerator divided by the denominator, we get this problem here now. Mathematically, this will cancel with this, and now our transfer function is IR divided by LSI plus LS squared RCI plus IR. Let me erase this side. Now, remember, the current here is common. Now we can say our TF is equals to I R divided by I is common. Is a common factor. We factor it out. LS plus LS squared RC plus R. Now this cancels this. Now TF, which is V O or V in, is equals to R divided by LS plus LS squared RC plus R. Now divide and numbers and denominator with R or resistor. Divide our size with R. After dividing with R divided by R over LS divided by R plus LS squared RC. Later we get 1. R divided by R is 1 divided by L over R S plus L over R S squared RC plus 1. Now, the 1 O over V in, we see that 1 over T 1 S plus T tau 1 tau 2 S squared plus 1 is the same as this one. Just the arrangements of the just the arrangement. So the 1 tau 2 S squared, the 1 tau 2 S squared, the 1S plus 1, and now that is the answer. Thank you for watching.